ex-colleagues I mentioned, Phillips, Days, and David is now at Siemens Mobility, based down in Paul, and he's going to be discussing the need identification, hopefully the slides up still, challenges, status of today with their CI environments, and their plans moving forward. So I'll hand you over to David.
Yeah, thank you, John. So I'm here today with a colleague, with Praveen, who's only been with us about 3 weeks, but he's part of his responsibility will be to pick up some more of the pipeline work that we've been doing. So do please speak to Praveen. He'll make my job a lot easier. We have a firmware team in our Siemens Mobility business in Poole. The firmware team has about 10 engineers in it, and on our site we have a factory that manufactures traffic controllers, traffic lights, signs and other products to support the movement of people through cities in the UK and across the world. Our factory in Poole actually manufactures the controllers for the UK and also for Germany, for our colleagues in Germany. So our prime job is to provide firmware and software to go into our traffic controls products. We're currently involved on for us, what is a very large project. Most of our projects tend to be small-scale embedded projects, which might involve 1 or maybe 2 engineers. But back in 2015, our marketing department identified the need for a revamp of our controller. And so what we're currently doing is we're distributing the intelligence from the cabinet out to the traffic lights. So before January 2017, which is two years ago, well, I started on this project from the beginning, so I've been working on this for about 4 years. It seemed to take an age to capture the requirements, to make and sell the business case to management, to get hold of the marketing department and say, please can we have the requirements in a form that we can actually use, and to also evaluate some target junctions just to see what the cost benefits would actually be and whether we could justify doing this project. We actually managed to scrape home and we got the go-ahead. During that time, we evaluated some quality improvement tools, and my R&D director was quite keen that we should have some common tools in place across the whole of Siemens Mobility. I think he had in mind the possibilities of Brexit coming up or something. He wanted to make sure that he could move the software development around within mobility, and for that reason we needed to use common tools. So we evaluated some tools, and at that time we selected Lattice and Clockwork for our static analysis. And we also looked into using VectorCast as well. I'll come on to those tools a bit later. January 2017, that's when the project really ramped up. So that's when we went from having 1 engineer to having about 4 engineers working on the project. I've mentioned a tool here, Stm32 Cube. The Cube tool, our processors that we use are ARM STM32s, and ST have a tool which is called the Cube tool, which you can use to just basically lay out the signals around the chip. You can use it to configure the signals, the DMA, the interrupt priorities, the clocks. And so I used this with my hardware colleagues as they were developing the schematics, and I said to them, use this tool to give me what's around the processors. And that was quite useful because it meant when we did the ramp up, when we started to have engineers come on board, we already had a Cube tool. I could already auto-generate code from the Cube tool using the HAL drivers that it had specified. And then all we had to do was just write the application firmware. We didn't have to worry about configuring the chips at all. So that gave us quite a quick startup on the project. That was important for us because we had a trade show within 3 months. So we had to have something up and running within 3 months that showed that what our factory had built actually worked. And we were able to do that. At that time, we use Eclipse as our main IDE. We were using CVS, which is like SVN, for our code management system. So there's a plugin for Eclipse that does CVS. Our compiler is a Kyle ARM compiler, so we had Kyle Microvision. And all those things, they have plugins for Eclipse. And the Clockwork plugin seems really quite good for Eclipse, seems to work well. And that's one reason why we chose Clockwork, because with the Eclipse plugin, the engineers can use the tool without really knowing that it's there. And it's another tools vendor wanted to come in and give us a 1-week training course on how to use their tool. And I thought, no, that's too last century. We need something that the engineers can actually use and pick up as they go. And yeah, Clockwork worked really well for us with the Eclipse plugin. At that time, we were using CVS, so we were using change sets within Eclipse to manage our code. And then what we would do is we would check the code in and then get an engineer to review what we'd just checked in. And that worked all right in the early days of the project, but we began to have real problems later on. We began to get pushbacks from our engineers on the quality tools. I think engineers tend to be lazy. They don't like to pick up anything new, and especially VectorCast was quite a lot to get their heads around. So although Clockwork was taken on board, VectorCast we never really got on with. VectorCast is for managing unit test cases. So our first cut of code was in 2017. The first build, it took us about a month. We had a traffic controller which we were putting outside the factory in the winter weather, and it was really miserable because it took us a month to get the thing up and running because there were lots of problems. And so that told us we had some issues to do with our technical debt and our continuous integration. And this slide, we had a consultancy from Verifa, who were some engineers who came in to give us a hand. And I thought this wrapped it up quite well. Our lead engineers are at the front, pulling this big pile of stuff, trying to implement functions, being pressed by the management to get these functions out. And then you've got people like me at the back saying, wouldn't you like to use these tools, these quality improvement tools? And they go, no thanks, we're just too busy, we haven't got time to learn. And so that's why continuous integration, I think, is such a good approach. It's a development practice that requires us to integrate code several times a day. And then each check-in then gets verified automatically. It allows you to detect problems early. The earlier you detect a problem, the quicker and cheaper it is to fix. So in February last year, so just about 12 months ago, we had a couple of Verifa engineers come in. We'd already had some consultancy from some Siemens colleagues who were working with our healthcare colleagues in the States. And they had actually migrated into Verifa. So that's why we had them. We already had a relationship. They came in, and on my laptop, they set it up with a Jenkins slave. And they managed to find a plugin for CVS that would work. And so they gave us a proof of concept in a week of a continuous integration pipeline using VectorCast and Clockwork. And the first time we ran the pipeline, we found a bug that had been in the code for about 3 years. So that was really quite an interesting result. And it proved the need to automatically integrate and test our software much more regularly. This was a function which is used at every startup of all our embedded targets. And it just so happened that there was an out of range variable that was out of range, and if you go down there, then the code crashes. So in July last year, we took the plunge. We recognised that CVS was the best way to go for us. And it so happened that Siemens were pushing the use of Code.Siemens, which is based on GitLab and GitHub. So we found there was a tool in our organisation that fitted our needs. We moved all our code repositories to Code.Siemens. We did them one at a time, and it took about a day to move each repository from CVS to Code.Siemens. And I would say that within a day, we had a basic pipeline up and running. And once you've done the first one, the others become much, much easier. So we tackled the first repository that we did was one that had already got through the majority of its features at that time. The reason for us using Code.Siemens or a GitLab-based system is it allows collaboration across our Siemens departments. We have a number of submodules, if you like, which are used by various projects, not just within our organisation, but within other Siemens departments. It gives a better security for our features. It gives us cost savings. And there's a one-stop shop. It's more than a source code repository for us. There's issue tracking, continuous integration is there. There's a Docker interface as well that can be used. We can use the shared runners, which are there to get access to the AWS and to Docker. And we've also defined two of our own group runners. That one there is my laptop, which I've got as a backup, just in case our main pipeline machine goes wrong. I can re-register my laptop and we can run the pipeline on my development laptop, which will make it a bit slow, but at least it gives us a disaster recovery. In July last year, Verifa came back on site. They helped us moving more repositories. We looked more closely at our pipeline. I would describe our pipeline as a pipeline on push. So what happens is the developers work on their laptops using Eclipse. They commit changes to their own local branches, and within that they can use the plugins that are on Eclipse. So the Clockwork plugin, the minute they save a file in Eclipse, it runs the Clockwork tool and it identifies any local issues. So hopefully they identify issues in terms of static analysis even before they push them up to Code.Siemens. So they're doing regular commits to their local workspace. And then when they want to push their changes to Code.Siemens, they might want it to be reviewed by a peer, or they might want to just back up their laptop just in case it crashes. Then they push the changes to Code.Siemens. People tend to push them quite regularly. And that triggers the pipeline. And down the side here you can see there's one of the showing a pipeline over a morning's work. That one down there is actually quite a big pipeline. That was on a master merge. So one of the lead engineers, they reviewed the merge request that went with this work, and when Code.Siemens merged that branch to the pipeline triggered some extra parts of the pipeline to run some more detailed checks, which don't normally get run if you're just working on a branch. A lot of these pipelines up here are just the pushes to the branch.
Can I just ask,
Yes.
those additional checks,
Yeah.
is that done when you do the merge request?
Yeah.
Is that done before the merge or post-merge?
Those checks are done before the merge. So what happens is the lead engineer will review the code, they'll review the results of the pipeline, and if they're happy with it, they'll then tick the merge button. And there's an option to say merge on successful pipeline. So they can say, yeah, I'll merge that, I'm quite happy with it. And then what the pipeline then does is it then runs the pipeline again, but it will do some additional checks. The additional checks include, when it runs on just the branch, it just checks to make sure the engineer hasn't included any more local issues, any new issues for clockwork. But when it does the merge to the master, it also checks the clockwork server, just in case another lead engineer has said, this issue, which used to be ignored, now needs to be fixed. So what can happen is the merge to master might actually fail because there's a legacy issue that someone else has identified as, in this project, needs fixing now. And so that might then fail that pipeline, and then the lead engineer who's done the review will think, hang on, that merge to master failed. And 5 minutes later they get a notification to say your pipeline failed. They go and have a look. They find out that one of the old legacy issues has now been flagged up as that's no longer acceptable. They then need to go and fix that on that branch. There's some additional checks as well. It'll actually run a vector cast stage also. We wouldn't normally expect that to fail. What that merge to master also does is it also uploads the artifacts. So any build artifacts that you define within the pipeline, they then become available in code.siemens for 6 days. So if you want, you can click on the little icon down the bottom there, and you can download artifacts. So you can pick up the result of your merge if you want it, to put it somewhere else, to try downloading onto your own target. If after the 6 days you want to recreate that, you can just rerun the pipeline, and then it recreates the
Do you run any tests, like a manual test before you merge with masters? Or it's all automated from your pipeline branches or teacher branches?
In code.siemens, you can trigger a pipeline on any branch, on any commit. If you go on to your branch, you can create pipeline.
So there's
and then
nothing of manual tests in regards to putting the code into a box or firmware or hardware and running manual tests. Do you involve that into your process, or that's
I can do it on my laptop. But what we have a general rule with our engineers, and that is that we expect them, prior to sending the merge request for review, they have to check that their changes actually run on their own rig and that the traffic lights come on. So unless it's a fix that is required, and because of compatibility issues with other bits of software, they can't do that. The general rule is, please don't ask us to review anything if it breaks the traffic controller. But on the whole, there's nothing within the pipeline that needs to be manually run. In fact, what most engineers do is they push it to code.siemens. They don't even bother checking clockwork, because they know that clockwork will find any critical error or warning issues. So they don't even bother checking. If I had a colleague last week, I think I mentioned it later, he came to me and he said, why has my pipeline failed? And when we looked at it, it was because he'd got a new laptop and he hadn't set up his Eclipse plugin for Clockwork properly. So it hadn't been running Clockwork properly, but the pipeline reflected the fact that he had introduced a new issue. A really useful thing that we found is that I call pipeline on pipeline. So in our embedded targets, we have a module called C Common, which is shared between all our embedded targets. Now that is a code repository in its own right, and it can be built in its own right. And the problem we were having was that other projects were updating C Common, and you might have finished your project, and then in 6 months' time, a customer asks for an upgrade of a feature, and you go, oh yeah, that'll take two weeks. It's a fairly simple change. But when you go and pick up the latest code and you pick up the latest C common, it's moved on to such an extent that you have a whole pile of other merges that you need to do to bring it up to date, which pushes on which delays your project. So what we've done is when anybody checks or when anybody does a push or a merge on the submodule, that triggers back into code.siemens a build of any application that uses it. And so what that means is that we get an early indication of a future requirement to do a merge. It tells us if anyone's basically broken our build. So we might have some of our enforcement colleagues who are working on a camera that make a change to C common for their project, which builds fine for them. But then we find that when it builds some of our projects, they then fail. And we can go back to them and say, please don't make that change. Or if you are going to make that change, can you make it in such a way that our legacy API still works? And the way that we do that is we run part of the pipeline in AWS. It does a curl request back into code.siemens using a token. Please don't use that token when you get these slides. But it sets this master build variable here to 1. And then when code.siemens triggers the main application pipeline over here, it runs a before script. And if the master build variable is set, then it does an additional checkout on the submodules. When it's building up the code on the pipeline machine here, that before script means it's got hold of the code from code.siemens, and then it then does an additional checkout of the submodule at its latest master. And then it will then build the application at its current master tag. And if the pipeline fails, then we know. And currently in our traffic controller product, we've got 23 submodules. And I think Praveen's picked up a story to to put pipelines in place for all of them. So.
What engine does the build pipeline this script?
This is a YAML script,
Yeah.
which is basic GitLab type.
What engine runs it? I mean, do you use like is it part of the Siemens GitHub that runs that build and runs the scripts and create the...
Yeah, the GitLab, it comes with something called Gitlab Runner, which is just a standard thing. And the Windows desktop machine, which is running this pipeline, has been registered as a Gitlab Runner. The second bit of the consultancy with Verifa was to try and improve our infrastructure. So rather than just use my laptop to run these pipelines, which made my laptop incredibly slow, we bought just a fairly standard desktop machine, which can run up to about, I've actually had it running 14 concurrent GitLab Runner pipelines, but it tends to bottom out about 10. But in practice, we find that we only get up to about 3 at any time during the day. And that pipeline machine just sits there, and it sits on our corporate network, and it's the same as any other machine. They came in, we asked them to try and get Lattice, which we'd used prior to this, to see if they could integrate that into the pipeline. We had mixed results there, partly because it took such a long time to arrange the licenses. And partly because our part of Siemens is very cash strapped. So our research director, he was quite keen that we should only pay for licenses if we really had to. So we're trying to get these licenses under some Innovate UK funding, which means that we can only get the licenses with part funded by them if we haven't purchased them ourselves. So we purchased these licenses as a subscription license on behalf of Verifa in their name. What Lattice gives you is it gives you just a dependency diagram and other things. So you can see at the top here, I've defined some rules to say that that anything above this diagonal is bad. So these are dependencies here that this common module has into the application. So that's like a cyclical dependency which you don't want to have. But most of these are due to legacy code, which we're not going to fix. So what I did was I defined a set of rules for Lattice which said any of these you can allow, but anything new, disallow. So that meant that if anybody put in a new dependency, then the pipeline would fail. That was the concept, but we never really got there. But at least we've got Lattice in the pipeline, and I'm hoping that at a future time we'll actually get it working properly. Vectorcast, we did manage to get into the pipeline. That again, the license for that was delayed. So it basically meant that we only had 1 month of Verifa, and the other 2 months I had to make up myself. But we actually got it into the pipeline to the extent that now we can trigger a Vectorcast run on the whole project. It takes about 8 hours, and so we run that on each project repository. We run that once a week. And we get out of the box with Vectorcast, it will generate a set of tests, what we call level 0 tests, and that gives us on average, about 40 to 45% code coverage on statements and branches, which doesn't sound much, but at least it's something. Some of the modules, the code coverage is even higher than that. We want to change our pipeline to get that Vectorcast based on a Git diff, because it's not really change-based testing. And Vectorcast has within it the capability to do change-based testing, but I don't think that's integrated with Gitlab Runner. I think that's more towards the Jenkins side of things. But with the pipeline now, we can do a sprint, what we call a sprint test build, within about 4 hours. And most of that is just paper, because we manually have to update the changelog. As the builds ripple up to the top of the controller, we tend to push the changelog entries up, and we do that manually at the moment. And as we put the various packages into the other higher level things, that in itself is an action on code.siemens, and each of those merges needs to be reviewed by a lead engineer. So it's just 4 hours really just to handle all the reviewing. But the pipelines run themselves. So, getting towards the end now, I think having some consultancy from somebody who's got experience of continuous integration does help to get things rolling. It allowed our engineers to continue to add value to the project. They were still able to work on their features while the consultants were able to get the pipeline up and running, and then work with us to try and get our other repositories into code.siemens as well. We had pipelines in use from day one. So on the first day, from moving our repository into code.siemens, we were able to run a basic build pipeline. The engineers can now work on multiple branches. So in Eclipse, they can just switch between branches at will. Some people are better at multitasking than others. Some people seem to handle 3 or 4 branches at the same time, but I just get confused. We were able to integrate with our existing tooling, so the Kyle Microvision compiler. If you can write a script to do it, you can put it into the pipeline. So the Kyle compiler, Clockwork. With Clockwork, we found out what to do by just looking at the log that was coming out of Eclipse. So we just looked at the Clockwork login view in Eclipse, and we could see what commands Clockwork was the Eclipse was doing. So we just copied those and put them into our pipeline. Doxygen, we now have a Doxygen stage in the pipeline. And that's been quite good because we're also putting that into our legacy code as well. So being able to get our existing tooling into the pipeline gave our engineers confidence that the pipelines were running. And having this automatic invocation of the application pipeline on a submodule merge gives us better reuse across our products. I've put up here, this is from Jira, this is one of our latest sprints over 2 weeks. And I wanted to show it because we're running fairly close to the grey line. So this is with the pipeline in place. If I were to show you one before the pipeline was in place, it would do sort of that. So, and down here, this is just on one of our main repositories. It's just showing the number of pipelines that we've run since July. So we really have only been doing this since July. Oh, and we also asked that we could have the pipeline available via Chocolatey install scripts. So on the back of our Siemens healthcare colleagues, we've just sort of borrowed their Artifactory instance. And we've got the ability to install Gitlab Runner and our pipeline support scripts onto any laptop, onto any machine using Chocolatey. And that works fairly well. So again, for disaster recovery, if our pipeline machine were to go down, I'm fairly confident that we'd be able to get our pipelines up and running again fairly soon. But I would say that licensing of our tools has caused us delays. So if you're thinking of putting tools into your pipeline, better if you've already got that tool in your environment, and if you've already been. And what we're finding now is that our engineers are going off-piste. So with continuous integration, at the beginning it was a bit of trying to push people and encourage people not to be afraid of checking things into code.siemens, not afraid of what the push was doing. But now we're finding that the engineers are beginning to think, oh, actually, I like this tool. I want to put that into the pipeline. And the more tools you get in the pipeline, the better. Even if they're doing the same job as Clockwork for static error analysis, they might give you a different perspective on a different issue. So I've got a colleague last week who for his project, he wrote some CU tests, putting those into the pipeline. It's a regression check that he wants to do on an algorithm that's checking for conflicts between traffic lights. We can now do our test builds within about 3 hours. And just last week, we sent a rig away to do some EMC tests. And at the EMC test stage, we had no test failures at all on the hardware or the firmware. And people were quite surprised at that. But I think that is due to the continuous integration. One tip I would say is that there are many ways to interact with your code base. We found that for us, some people like Tortoise Git, some people like Git for Windows. I like Eclipse. Everybody has their certificates. Just let people use whatever they want to use. And this just shows you, on our wiki, we have the current state of our various plugins and submodules. So it just gives you an idea. If any of these go red, then we know someone's broken it. So here's some final comments. That's the chap who came to me and said, what's gone wrong? We like to have separate work on branches. It allows us to review and resolve actions before the merge. The visibility of the history is clear. Git and GitLab are standard products, so there's a lot of help available on the internet. The checks of the pushes and merges are done by pipelines. So all people have to do is just review the code changes, and they're confident that the pipeline will actually find any real issues. Build artifacts are available from the pipeline, so you don't have to build it yourself and then remember to move the hex file from here to here. It was introduced quickly and easily into our ongoing project. Improved framework for managing codebase. Eclipse seems to have poor support for Git, particularly submodules. So watch out. Some people in our team seem to get really worked up about this, but I don't have a problem. Don't know what the fault is. Anyway, recommend using the command git line for Git. So, and that's my details there. If anybody wants to jot them down. Any questions at all?
One problem we've had is actually generating the pipeline script, because there seems to be so much information on the web, a lot of it conflicting with each other. We started off with Jenkins. We tried to import a lot of the Jenkins stuff into a pipeline in GitLab, and it just wouldn't work.
Yeah.
And finding the right plugins that Jenkins was using to implement into the pipeline, it was just a horrible mess.
Yeah.
So we rolled it back and we just stuck with Jenkins.
Okay. We've never used Jenkins. So our GitLab Runner pipeline is all handcrafted. So I'm afraid I can't say too much there.
Did you generate that yourself, or was it the support company who started you off on generating that script?
No, we generated the script ourselves. The consultancy, they gave us some advice, and they worked on a separate branch to us. And so from time to time we merged their YAML scripts onto ours. They were particularly useful in getting this submodule trigger working. But we were advising them on, we were saying, well, this is what we think we should be using for clockwork. And they went away. Rather than us get the pipeline running, they got it running. But we were the ones really who were writing the script. Yeah, and to be honest, on the code.siemens website that we were using, the help for it was fairly okay. But I have heard that there are problems getting from Jenkins into GitLab. Yeah, so, but I'm afraid I can't be much help there.
With all the pipeline, the majority of the stages, if you like, are static analysis. How, maybe loaded question, how often when you take the result of that pipeline and actually put it on the real physical device that you're essentially selling, do you find that you've still got issues? Because one of the challenges we've always had is no matter how much effort we can put into static analysis, you never find all the problems.
Yeah.
To the extent where we've deprioritised static analysis at the attempt of always trying to deploy to the hardware, because we've sort of decided that running on the real thing is going to give us a different set of problems to solve.
Yeah.
But it's just because we could never get the coverage high enough with all the static analysis to give us the confidence that, of course, it would just work.
Yes, yeah.
Interesting.
Yeah. What we do is we run on a 2-weekly sprint, and we do what are called sprint test builds. So whenever we get a set of stories, we would then do a full build, which takes about 4 hours, and then we would load that onto 3 test, and then we would check those stories. We also run a small set of regression tests manually as well. But we are looking to move to continuous deployment. But we don't do that yet. But with static analysis, what we found is that over time, the number of issues you find go down. That's mainly because the engineers are being trained, without them realising it, into not introducing the issues in the first place. But I do find that we have a pile of issues that are review, which the engineers don't look at, and which the pipeline doesn't actually look at. And so I do encourage our engineers to actually, when they do a code review, actually look at the issues that are at review, just in case there's any in there that might trigger a, hang on a minute. And the other thing that is useful is we can trigger our pipeline to run vectorcast on a particular file. And although VectorCast will only give you its automatically generated code coverage, any paths that it hasn't gone down or been able to go down, you can then look at it and say, something I need to be writing a unit test for, or maybe that's something that I need to pay attention to in my sprint test. So, yeah.
There are two licensing issues that you presented. The first was a delay in getting the license.
Yeah.
And the second one was the company money being tight and
Yeah.
aversion to commercial options.
Yeah.
A number of tools you presented, demonstrated, are commercial tools. Were there open source equivalents available? Did you consider them? So for
That's a good
coverage
question.
and
Yeah.
static analysis,
Yeah.
I believe there are open source
Yeah,
tools available
yeah.
for them.
Yeah.
Was it company policy to go for commercial?
It was more a question of, in the back of our minds, we've got, in our industry at the moment, we don't have to have a certification to SIL 3 under the Industrial Functional Safety Standard. But we're aware that if a customer were to ever their tender and it became commonplace, then we might have to we might need to be able to make an argument for getting that certification. So it's more that we're more concerned about having tools that have that SIL 3 level under that, and also the ISO 262 for the automotive standard, because more and more of our work now is done with vehicle to infrastructure, and some of our modules are common modules. So although in our project that's not a concern, it might be for our enforcement colleagues. As you mentioned that, there was something that came to mind. Oh yes, that is, some of the licenses we've got are more expensive than others. So our compiler, we have a certified compiler license, which is a single license, single node lock license. We have that on our pipeline machine. But our engineers have standard licenses on their laptops. So when they're working on their branches, they're just using a cheap standard license. But then when the pipeline runs, it actually runs the certified compiler license. And that's also sort of true for Clockwork. The build admin license, which is more expensive, which we've only got one, is on the pipeline machine. But the more common licenses for just running Clockwork are on the developer machines, if you like. So you can be creative in how you deploy your own licenses.
Okay, if we can hold any further questions till break or during some of the breakout sessions, because I'm just aware, once again, I'm running away from my chair.
Yes, right.
So I'd just like to say a big thank you to David for the presentation today.
Yeah, thanks.